It's time for video lesson number 21, and today we're going to be talking about how to solve one-step linear equations. For this lesson, you will need your TOC number 21, that's the yellow sheet you were given in class. You will need a pencil or pen to take notes. It's always helpful to have a highlighter, marker, or colored pencil to help you just in case. And this is part of the calculator unit, so you can use calculators. So if you have your phone handy, or you can download the Desmos app and use that. All right, at the very top of your paper, this is crucial and critical, so you're going to want to write down this whole thing. So you may want to pause the video to make sure you get all of this down. Just like in real life, one of our mottos at our school is to be kind and that kindness matters. So I know you've heard this in real life, is to treat others how you want to be treated. Kind of the same thing in math. We learned when we talked about algebra vocabulary that an equation is two expressions that are set equal to one another. Well, if they're equal, you can't do something to one side of the equation and forget about the other side, because then they're no longer equal. So the golden rule of algebra says whatever you do to one side, you have to do the same thing to the other. You got to do the same thing to keep both sides equal. So whatever you do to one side of the equation, you must also do the other side to keep both sides equal. Take a second, pause the video, make sure you get this whole saying written down in that box. All right, now that you have the golden rule of algebra, whatever you do to one side, you have to do the other side, let's talk about the goal of solving equations. Whenever we solve equations, remember an equation, you've got a variable and then you got a bunch of numbers, constants. The goal of solving an equation is to isolate the variable. The variable is that letter. So the variable is the unknown. It's something we don't understand. We don't know what it means. But we want to isolate the variable and get the variable or letter by itself so that we can find out what it means or what it represents. So when we isolate or get it by itself, then we understand what that letter means. So at the end of solving an equation, we understand that x equals 7 or x equals 5. And then by that, we have solved the equation. We now know what the letter means. And when that happens, we've solved the equation. So that's what solving equations means. You're figuring out what the missing piece of an equation is. So the next step is to figure out how do we solve an equation. And it's not that bad. Right now in 6th grade, they're all one-step equations, meaning there's only one operation. So it's either going to be addition, subtraction, multiplication, or division. When you get to 7th grade, 8th grade, and up higher, you're going to have 2 steps. You're going to have operations on both sides. You're going to have to combine multiple steps, things like that. But for now, you just have one step. So, and it's very simple. We just talked about properties, and we talked about how the inverse property is going to be huge. So, how are we going to solve equations? You use the inverse or the opposite operation. So the additive inverse property and the multiplicative inverse property are going to be huge. So the inverse of addition, that's when we're adding a number. Then in order to undo addition, we're going to add the opposite, which is adding a negative. And we know from our integer unit, that's the same thing as subtracting a positive. So the inverse of addition is just subtraction. The inverse of subtraction is the same thing as addition. So write that in, and we're going to go through this in class, so don't get confused. But basically, this is just the additive inverse, taking the positive or the negative whole number and using the opposite. With multiplication, and with the additive inverse, you end up with 0. With multiplication, it's a little bit different. If you're multiplying, your inverse is going to be to divide or multiply by the flip. If you're dividing, you're going to multiply as your reciprocal or multiply by your inverse operation. And when you use your multiplicative inverse, you don't get 0, you end up getting down to 1. So again, you're just using your inverse operation or the inverse property, whether it's additive inverse or multiplicative inverse. And we will go over this in class, so it's a little bit more clear, but we're going to take a real quick minute to go over some examples so you understand. So let's look at 2 addition subtraction examples, and then you'll understand how we use the inverse property. So for our first example, we have x plus 12 equals a negative 37. Since I have x plus 12 equals negative 37, I want to get the variable by itself, meaning I want x all alone on the left side. Since I have a positive 12 with the x, I want to undo that positive 12. So I want to add a negative or just subtract 12. So here's my inverse. Subtract 12. Whatever I do to one side, I gotta do the same thing to the other side. Otherwise, it gets unbalanced. And we saw that when we did it with the scales and candy in class. Once I do that, a positive 12 and a negative 12, we know from the inverse property is going to equal 0. So on the left side, now all I have is x. So now x is going to equal whatever I get on the right side. And a negative 37 plus a negative 12, they're both in that negative battle box. I just add them together and I get a negative 49. So now I know that x equals negative 49. So that's my answer. X is now negative 49. Now, the cool thing about algebra, this is why I love algebra, is there's a method that you can use that you will never, ever, ever miss one of these problems if you do this correctly. It's called the check step. And what you do is you take this answer, x equals negative 49, and you plug it back into the equation that you started with. So I started with x plus 12 equals negative 37. And I'm going to put my answer that I had, x equals negative 49, and I'm going to put negative 49 in there. So let's check it by putting, now that I've put negative 49 in there, let's see. And you get a calculator, so you can't make any calculation mistakes. Negative 49 plus 12 should give me negative 37. Now here's where students make the mistake. They don't take the time to really add it. Negative 49 plus 12, I actually do get negative 37. And keep the negative 37 on the right side because that's saying that that was what I was supposed to get. If you get the same thing on both the left and the right side, then ding, 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 you're golden. That's saying my answer is correct, and I really did double check it. That check step is there for you to say, yes, ding, I checked it, I know it's right. And if you do that check step and you do it correctly, you'll never ever miss one of these questions on your test and you'll get 100. The students that kind of just go through the motions and they're not owning their own learning, they're the ones that are going to make mistakes. Let's look at the subtraction problem. So now I have 12, and it's okay that it's confusing because it's kind of, oh wait, I got 12 equals x minus 4. It's okay. It's still the same problem. It's just this time the variable on the right. Don't worry about it. It's just backwards. We can still solve it. Look at where the variable is, and that's the side we're going to solve. So x minus 4. So instead of subtracting, we're going to do the opposite operation this time. Instead of subtracting, I'm going to add because it's a negative 4. So let's add 4 to both sides. Remember, whatever I do to the right side, now I got to do the left side. So a negative 4 and a positive 4 are going to equal 0. So now I'm left with just an x, and 12 plus 4 is going to give me 16. So now that I've got my answer is x equals 16. If I plug it into my original equation, instead of x, I'm going to replace that with 16. Now I have to just ask myself, what is 16 minus 4? That equals 12. And I already had 12 on the other side. If I have the same answer on both sides, that tells me my answer is correct. And that's all you're doing. You're solving to find out what x equals, and then checking your answer. So that's addition and subtraction, probably the easiest side of things. Let's try multiplying and dividing. So on multiplying, this is multiplying because it's right next to the variable. It's a negative 6 times x. So we're going to divide. Now I showed it like this with the division sign. Normally we're not going to do that. We're just going to draw the division bar. So we're going to kind of make it as a fraction. So it looks like negative 6 divided with the fraction bar. But I didn't do that this time. I'll show you that in class. So it's a little bit less confusing. But if I have a negative 6 and I divide a negative 6, I'm going to just get 1. And if I have a 90 divided by negative 6, remember you can use a calculator. So I know that's a pretty big number. But if I have a positive divided by a negative, I'm going to get a negative 15. So my answer is x is equal to a negative 15. And then if I plug that back in, 6 times my answer, let's replace that with a negative 15. A negative times a negative, 6 times 15 gives me a positive 90. And that's what I should have gotten. That's what I started with. So my answer is correct. And the last one is a division problem. So I'm going to solve using multiplication. And since I'm dividing by 12, I'm going to multiply both sides by 12. And this is how we show multiplication. We're going to show that we're multiplying using parentheses. And since I'm multiplying and dividing, I'm going to cross cancel those. On the left, 7 times 12 is an 84. So x, my answer is x equals 84. So now let's plug that in. Instead of x, I'm going to replace it with 84. 84 divided by 12 should give me 7, and it does. So my answer is correct. So overall, it's not a hard concept. You get a calculator. They are going to throw some fractions and some decimals at you with this. The main thing is that you are showing your steps. Students get into trouble because they do not show their work like this. And this is critical because if you're not showing your steps and you're not taking the time to show it correctly, when you get to harder problems that are 2 steps and multi-steps where you've got variables on both sides and you've got to combine steps in the later grade levels, you will make huge mistakes. And so we're starting with baby steps. So make sure you take the time to show your work. And now it's time for you to log in and show what you know. But before you do, I want you to draw a square around the TOC number 21 on the front page in the top right corner. Draw a square around the TOC 21 in the top right corner.